Hey everyone, my name is Jeremy McPeak for NetTuts, and this is part 2 of a series called Building Your Own JavaScript Library. In part 1, we talked about events and how we interact with the user with events. Well, user interaction is just part of the JavaScript developer's story. We also want to interact with the web page that's loaded within the browser. So in this part 2, we are going to look at how we can do that, and we do that in two different ways. We can change how the web page looks by changing individual element style, or we can change the content of the page. And we're going to get started with style because that's kind of the easiest. There are two different ways that we can change an element style. We can change individual CSS properties, or we can change the CSS classes that are applied to an element. We're going to start with the easiest, which is changing individual CSS properties. We do that using the element's style property. Now, we are going to follow the same development philosophy that we did in lesson 1. We are going to write some static methods that we can use using raw DOM objects, and then we are going to write some instance methods for XObject instances that are basically going to call those static methods. So we will have the same type of code reuse that we did in part 1. And our code is broken into sections, if you will. We have instance event methods, and then we have static event methods. So we're going to create another section called style static methods. And we need a method to change individual CSS properties. The convention, I believe, is CSS, and if it's not a convention, it just makes sense, because if we were going to just look at our code, we can infer that a CSS method is going to change the CSS of an element. So we'll do equal function, and we need three pieces of data. We need the HTML element to work with, so we will call that EL. And then we need the CSS property name that we want to change, so we'll call that CSS. And then we need the value to set that CSS property to, so we'll do value. And then we'll write the easiest code probably within this entire library, and that is changing the style of this particular element. So we will do L.style, and then we are going to use bracket notation here, CSS equals value. We've used bracket syntax quite a bit throughout our library. In fact, you can see it 5 times here on this screen alone. If you're not familiar with bracket syntax, you can think of an object as a set of key value pairs. We have a property, which actually has a property name, and that is the key, and then there's a value associated with that property name. So for example, if we wanted to change the color of an element, we would do something like this, where color is a property name, and we set it a value. So when JavaScript executes this code, it's going to look for a color property, it's going to find it, and then it's going to set it a new value. Well, we can rewrite this code, and it would execute the exact same like this. We are passing a string value here. This is the key, and then we are setting the value of red. So color is a string, and we're using the bracket syntax to do that. Now, if we look at our CSS parameter here, and if we try to use dot syntax, the JavaScript engine is going to try to find this CSS property. It's not going to find it. That's not a valid CSS property. So it's going to create one and assign it a value of red, and obviously that's not what we want to do, so we want to use the bracket syntax, because we are passing a string value to CSS. In fact, let's go ahead and do that here, CSS. Let's assume foo is an HTML element object. We'll set the color to red, and let's go ahead, get rid of that line. So we are passing a string value here. So instead of using the dot syntax, which is going to result in our code not working, we use the bracket syntax, because we can pass a string value to there and be able to change whatever CSS property that we want to. Now, as it is right now, CSS really isn't very helpful because we can write some raw JavaScript that would actually execute faster and it would actually be less typing. As we can see here, there's several characters difference between these two lines, and with the call to CSS, we have added a method call, which is going to slow down our code execution just a little bit. So we need to add some features to the CSS method to make it just a little bit more usable. Wouldn't it be nice if instead of passing two string values here for the CSS property and the value, that we could pass an object, and it would contain multiple CSS properties and values that we could set all at one time. So we could do one method call and we can change multiple CSS properties. So we could do something like color and then red, and then let's say background color and blue. And then we can just keep listing CSS properties and their values all day long, and we could do that all with one function call. Now, seeing this CSS property reminds me of something. Unfortunately, in what I call legacy IE, which is IE 8 and below, if we pass a string containing a hyphen for a CSS property, that's not going to work. And that's because the style object does not recognize any hyphenated CSS property. Instead, it only recognizes the camel case version. So we have a slight little problem here in that we need to address for legacy IE. Now, IE 9, Chrome, Safari, Firefox, Opera, it doesn't matter how we pass it. We could pass hyphenated or camel cased versions and it would work. Now, we could specify that you can only pass camel case versions, but it would be a little bit more friendly if we could pass any CSS property, be it hyphenated or camel case, and it would just work. So we need to write a helper function to convert hyphenated CSS properties into camel cased version C or camel cased CSS properties. So we are going to create a new little section here, call it helper functions. And this helper function is going to be called toCamelCase. It's going to accept a string value, and then it's going to return a string value. Now, one thing regarding the global scope. Right now, everything is global. And of course, we will add some encapsulation later on, but it's important as we are developing our library to keep things as simple as possible. We don't want to include any more complexity than what's necessary. And in our case, we don't want to introduce any closures or anything that may make debugging our library a little bit more difficult. So by keeping everything global right now, we have a better chance of finding bugs and fixing them a little quicker than we would with using closures or something else. So back to the toCamelCase function, we want to return a string that is going to remove the hyphen and then uppercase the letter after the hyphen. So we're going to use a regular expression to do that. But first we're going to call the replace method that every string object has, and then we are going to pass a regular expression as our matching pattern. And in that pattern, we want a submatch. So we're going to use a parentheses. We want a submatch because not only do we want the hyphen and then the character after the hyphen, but we just want the character after the hyphen to work with, because we need something to use for to transform into uppercase. So we're going to use parentheses, and then we are going to specify A through Z because we want to match those characters. Close parentheses, and then we want to ignore case, and we're going to use global processing. Now the replace method is very flexible. Not only can we hard code a string value to replace to like that, we can specify a function that will execute with every match that's found. And this particular function can accept any number of parameters. In fact, with however many sub matches we find, we can have as many parameters and then some, because there are some that are specific to this particular function. But we really only need two, and of those two, we are only going to use one. The first parameter is the match that we are working with. Some people call it all, some people call it match. I'm going to call it all because it's only 3 characters. The second is the submatch, which in our case is going to be an individual character, and actually it's going to be an individual letter, so I'm going to call it letter. If we had another submatch, then we can add another parameter here for as many submatches as we need, but we only have one, and we need to return a string from this function here, because whatever is going to be returned by this inner function, or this function that's going to be executed within replace, that is going to be the character that is going to be replaced with. So we want to return, and then we just simply want to call to uppercase on the letter. So this is going to match every hyphen and then the character after, and then it's going to replace that little substring with an uppercase character. So now let's go to our CSS method, and we will just call to camel case, and then regardless of what browser the user is using, be it Legacy IE or IE9 or Chrome or whatever, this is going to work. Alright, so let's go back to this CSS method call. We want to be able to pass an object that contains properties that mimic the CSS properties, and set the values for those properties. So we need to add some logic to our CSS method in order to handle that. Now we could add another parameter. We could call it CSS object or something like that, but that just adds more confusion and more bloat to our code. We want our API to be very tight, very easy to use, very easy to remember, and just adding another parameter isn't going to do that. So we are going to get the types of data that are passed to this CSS and value parameters, and then we will write some intelligence that will make the CSS method behave differently according to the types of data passed to those parameters. So the first thing we'll do is we'll create a variable, and this is going to contain the type of data that was passed to the CSS parameter. So we'll just call this CSS type of CSS. Pretty easy. We'll do the same thing for the value parameter. Call it value type of value. Now, we need to determine what we need to do with this information here within CSS type and value type. If CSS is an object, then we want to enumerate over the properties of that object and set the CSS properties to their appropriate values. So let's go ahead and write the code to do that. We'll just use an if statement. If CSS type is not undefined, and if value type is undefined, that's right, then we want to do something. Now the reason why I did this is because we are actually going to add more capability to the CSS method regarding the CSS parameter here. So that's why I'm not checking for object right now. We're going to do that with another check. So if CSS type is object, then we want to enumerate over the properties. So we're going to use a for in loop. And the problem with the in operator is that it is very greedy. It looks at the object, but it also looks at the object's prototype chain. So if you have a property that is on the prototype chain, the in operator is going to find that property and enumerate it. We don't want that. Instead, we want to just filter out everything else on the prototype and just look on that object. So we want only the properties that are explicitly assigned to this object. So we are going to use a method called hasOwnProperty. It is on the prototype of the object data type. So we'll do CSS has own property, prop. Then if that is the case, then we want to set the CSS style. So el.style, we're going to use bracket syntax again, the property, and then we are going to set the value, so CSS prop, and that's pretty much all that is there. It would be good to add an else block here, because there are times when developers will pass in data that is really not expected by the method. I know it's crazy, I've never done it, and I know you haven't never done it, but it would be great if we could at least get a message telling us that we pass some type of data that's not supported. So we're just going to throw an object, and you can throw anything in JavaScript. It doesn't have to be an error. I know we've thrown an error before in part 1, but since then I've gotten lazy, and it's just great to pass an object with a message property, and this message property is going to be used by the browser to display the error message in the console. So we'll just say that invalid parameters passed to CSS. That's not the best error message, but it works. Okay, so we've handled the object portion. We need to then write in the intelligence to determine if CSS is a string and if value is a string to set individual CSS properties. So we're going to add an else if, and if CSS type is a string, and where's and value type is string, then we want to basically use this code here. Pretty easy, and we'll add another else block. Doing the same thing here, we're just going to throw a message, or throw an object with a message property, and that's that. And something else we need to do, we need to call toCamelCase up here. That would be good. Okay, so we have a working method here. The only issue that I can see right now is with this line, el.style, and then toCamelCase, blah, 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 blah. And the reason I see that this could be a problem is because we're doing it within a for loop. So there's really no telling how many properties this CSS object could have. It could have 1, it could have 2, it could have 10, it can have however many that we want to do. So we want to make this as efficient as possible. Right now, this code is causing the JavaScript engine to look up the L variable. It's got to find that variable within this scope, and it's going to find it, and then we use the style object. So every time that this loop executes, it has to look up the L variable, and then it has to look up the style property on this L object. So we can make this a little bit more efficient by caching that value. We're going to create a variable called lStyle and just set el.style. So now we can use this variable here. And instead of doing a lookup for the variable and then a lookup for the property style, we just look up the variable el.style, and then this is going to speed up the execution a little bit. I mean, with today's just-in-time compiling engines, is that really necessary? Probably not, but hey, fast executing style makes me happy, and I hope it makes you happy. And we are going to change this down here as well. And the reason being, because we already have a reference to it up here with the lStyle variable, we might as well use it instead of getting the, or at least duplicating this lStyle again. So we have a better functioning CSS method now. Let's add some more capability to it. Because we do have some better functionality, we can pass in single CSS properties. We can also pass in an object containing multiple CSS properties. But something that would be nice if we could pass just a string containing a CSS property and then get the value of that CSS property that is applied to the element. All we need to do is add an else if statement, because we already have the logic determining the types of data that's being passed here. If we're passing just a string to CSS and value is undefined, then it's going to fit within this if block here. So let's add an else if, and then CSS type is a string, then we want to do something. And that something is called a helper function to get the CSS style. So instead of writing the function right now, we are just going to write the code that executes it. We're going to call that function getStyle. We're going to pass it the element object and then the CSS property that we want to obtain. And that pretty much finishes the CSS method. Of course, we need to write this getStyle function. And the reason why we need to write this function is because, surprise, surprise, we have different ways of doing that depending upon the browser. With Internet Explorer 8 and below, we have the current style object that we can use. If IE 9 and all the other browsers use the standard DOM means, which is the getComputedStyle method. So let's go down here, and we are going to write this function a little bit differently than we did the event methods here. Because we were setting multiple methods depending upon the browser type, we grouped them all within their own if statements, and it was just a little bit cleaner to do it this way. With the getStyle function, we just have one function, so we are going to call a self-executing function that's going to return a function to getStyle. So let's go ahead and write just the bones here. And we have a function that is executing. But of course, right now it's not returning anything, it's returning undefined. So we need to write the code to return a function to getStyle based upon the browser that the user is currently using. We'll first check for standards compliance. Now, the actual standards call for document.default view.getComputedStyle. So if we were going to do it this way, we would have to first check for document.defaultView, and then we would need to check for getComputedStyle, because there's no guarantee that if this object is supported, that the getComputedStyle method is supported. That's a lot of typing. Even though I just did that, we're not going to use it. Instead, thankfully, every browser that supports getComputedStyle also makes it a method of the window object. So we can just do type of getComputedStyle does not equal undefined. Then we can do something. Now, I did omit window. I know all the cool kids put window, but I'm not cool, so I'm not doing it. So we need to return a function. It's being passed the element object and the CSS property name. So we will return getComputedStyle, and this needs the element object. We're going to pass null. The second parameter is for pseudo elements. We're going to pass null, and then we call the get property value method and pass CSS prop. And what's great here is that it doesn't matter what that CSS property is. It could have a hyphen, it could have camel cased. We're going to get that value regardless, so we don't have to call to camel case. Now, unfortunately, I can't say the same thing for Internet Explorer, so we're going to return another function. Same parameters. And we will call l.currentStyle, and we have to call to camel case. We'll pass CSS prop, and that's it. Now there's two things that we need to remember here. First, get computed style and current style are two completely different beasts. Get computed style actually returns the computed value. So let's say we have a div element that is 100 pixels wide, and it has a child element that is set to 50%. It's explicitly set 50%. It's not giving a pixel value, it's a percent value. The get computed style method is going to compute that width for us. So if we call get computed style and we're looking for the width, it is going to compute 50 pixels because 50 pixels is 50% of 100. Now with current style, the current style object just gets the value that was set to that particular property, be it in the style sheet or the inline property. It does not compute anything for us. So in that same situation, if we were to get the width of that child element, it would say 50%. So there is the possibility of getting two completely different pieces of information from our get style function. We will just need to make sure whenever we are setting our CSS properties that we take that into account. And of course, whenever we use get style or use the CSS method which calls get style, that we make sure to keep that in mind. There are some workarounds. I have seen quite a few developers work around that, but we're not going to get into that because that's magic, and I don't deal with magic. The second thing is, if you look at our event code that we wrote in part 1, we first tested for standards compliance, then we tested for IE, and then we had a fallback. Well, we are assuming here that if the browser is not standards compliant, that it is IE. And that's because there really is no suitable fallback. If it's not one of those two browser types, then chances are pretty good the browser isn't going to have any type of capability of getting style information. Now, we could do something like el.style and then CSS prop, but that's also making the assumption that whatever property is set here or that we are requesting here was set through the style object. So there's really no suitable fallback for get style, so we are just going to assume either the browser is standards compliant or it is legacy IE. And this finishes the getStyle helper function. And by finishing this, we've basically finished up the CSS method. So before we test this, let's go ahead and write the instance version of it. So we will add a new little section here. We'll call it instance methods. Let's get rid of this code because that was just there for pseudocode reasons. And we want to write this instance method, so we will put it on the prototype. We'll call CSS. Now remember that XObject instances wrap around an HTML element, so we already have that reference. We don't need to specify it in the parameters. So all we need are the CSS and value. And then we call XObject.css, we pass in the L property, and then we pass through the CSS and value. Now, we want our instance method to return one of two different types of data. We need either style information or we need a reference to this particular instance, because that will allow us to chain the CSS method if we need to. So we are going to use some shorthand syntax. Instead of using if and else and all that wonderful stuff, we are going to use a logical OR operation. And if you're not familiar with this type of syntax, a logical OR operation performs an operation on two operands, a left side and a right side. So we have a left side here, and then we have a right side, which is this. With a logical OR operation, the JavaScript engine first looks at the left side, and it will evaluate that left side and determine if it's a true or false value. Well, in this case, if we call CSS and we want CSS style information, then it's going to return a truthy value because it's going to return something other than null or undefined or 0. So we will get a truthy value, and so the logical OR operation will stop there, because with a logical OR operation, either the left or the right side has to be true in order for the whole condition to be true. So the JavaScript engine will look at this left side. If it returns a truthy value, then it's going to return that value. So in our case here, if we call CSS and we pass in color for our CSS parameter, then let's say we'll get red back. That's going to be a truthy value, so we return the value of red. Now, if we call CSS to set CSS style, then the CSS method is going to return undefined because we don't return anything from our static method here. We just return something when there is a need to get style information. And a function that does not return anything actually returns undefined. Undefined is a falsy value. So when we get to this logical OR operation, it's going to call CSS. It's going to return undefined, so then it's going to go to the right-hand operand, and then it's going to return that. So that's how this little statement works. It's a nice way to return one or two values, and it's a whole lot, in my mind, cleaner than using an if and then an else. Let's test this, and we are just going to test the instance version because that calls the static method, and this code really isn't going to fail here. So if we have an error somewhere within our CSS method or the helper functions, then we should be able to spot that pretty easily. So let's go to our HTML file, and this was from part 1. We are using this underscore CSS property, which we created in part 1. But one thing to always keep in mind whenever you're writing software is to never be afraid to change your original design, such as this underscore CSS method. Originally, that was going to be there so that we could use that object, which maps to the element object's style property. But since the design of our CSS method doesn't really need that, then we can actually go and get rid of that underscore CSS property. But we'll do that later. We're not going to worry with that too much right now. We already are getting this particular element here. It has an ID of foo, and so we are getting that element and wrapping it within an X object instance. So let's go ahead and get rid of this click method, and we just want to call CSS, and then let's pass in color, and we'll set it to red. So let's see, there's no easy way to start this, is there? Nope. So we will go to here, 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 and here. Of course, your mileage may vary, and we are getting red text. Now this is IE9, and we should be in IE9 mode. We are. Let's go ahead and switch it to IE8 mode, and we are still getting red text. Let's go ahead and open Chrome so that we don't have to go in and out of the different IE modes. And if it works in Chrome and IE, then with something this simple, it's safe to assume that it's going to work in pretty much any other browser. So our two string parameters here work fine. Let's pass in an object and set some multiple CSS properties. So we will just do that. We'll do color. Let's change that to red. As a background, let's test it like this. Background color, let's set it to navy. That needs to be in quotes. And that really should be it. Yeah, let's just leave it like this. This will test the normal CSS properties. We can assume that the camel case versions are going to work. We primarily want to test this hyphenated version. So Let's save it, go back in IE. Let's see, we've got the color, but we don't have the background color. Let's look at the console. Leading is undefined. I don't remember typing leading. That is line 151, so let's look at line 151. And that would be why instead of letter, I put leading. I'm sorry about that. I'm sure you were screaming at the screen telling me that that was incorrect. But this should work now. There we go. Chrome. Great. So now let's get some style information. And we will just get color. We also need to alert this. We'll do it the old-fashioned way. There are better ways, but hey. RGB 000, that's black. And we should actually get a hex there, and that is fine. So our CSS method is working just fine, both the instance and the static methods. So let's start looking at how we can modify element style with CSS classes. The basics of CSS classes are pretty easy. In HTML, we have a class attribute that we can use to set CSS classes to an element. And then in JavaScript, we have a class name property which maps to that class attribute. But one thing you may or may not know is that we can set multiple classes within a single class attribute. All we have to do is separate them with spaces, and we can keep adding them as we see fit, but we'll just go to 3 here. We can do the same thing with the class name property. So whenever we look at CSS classes within our library, we need to take this into account. We need to be able to add one or more CSS classes, and then we need to be able to remove one or more CSS classes. It would also be helpful if we could determine if a particular class was applied to an element, and then we are going to add a fourth method that basically toggles a class on or off. For example, if we wanted to toggle foo here, then it would actually remove that class from the element. But if we were to toggle it again, it would add foo back. So that's 4 methods. One to determine if a CSS class is assigned to an element, so we're going to call that one has class. One to add CSS classes, we'll call that add class. One to remove classes, we'll call that remove class, and then the toggle class. So let's go back to our code, and we will start with these static methods first, and we'll start with the easy one, has class. And of course we need the element to work with, and then we need the CSS class. We're not going to worry with multiple classes here, we just want to search for one class. When working with CSS classes, we have 2 approaches. We can use strings, and in the case of has class, we would search the class name property for a substring, or we can use arrays, and we would basically parse the class name property into an array and then search the array for a particular string. Really depending upon the browser that executes the code, one or the other is going to be faster, but for the most part pretty much everybody uses strings, so we're going to use strings as well. We need to return true or false here. So the easiest way to do that is to el.className and then call index of, and then search for that particular value. Now there are some bugs with this particular code. Let's say that we have 2 classes that are assigned to an element. We have bar and foo2. And let's say that we are searching for foo. Now, if we are going to use this code here, what this would actually do is return true because foo2 has foo. Of course, that's incorrect because we want just foo, not foo2. So we could surround that with a single space. which basically makes foo its own little word here. So if we are going to search bar, of course, that's not going to match. And now foo2 does not match. But let's say that we have foo and then foo2. Well, we are searching for foo, and foo's here, but this isn't going to match because we have space, foo, space, and we just have foo and then space. So since we wrapped our search term with single spaces, we need to do the same thing with the CSS classes that are assigned to the element. Now, whenever we would do this search, we would get true because foo is here. And of course, if we added a foo3 instead of a foo, this would return false because we are searching for space, word, and then space. So we need to change our code here so that we surround el.className with a single space. And that is easy enough to do. And then, of course, we want the index of, but then we need to do the same thing for our value. And that's it. As I said, this is the easiest method that we are going to write. So with that, we will move on to the add class method. It's just a little bit more complex than the has class method, but it's not too bad. We need the HTML element and then the value. The value can contain one or more CSS classes, so it can have foo, or it could have foo and then foo2 and then foo3. I'm going to leave those comments there for now. The first thing we want to do is cache the element's class name property, because what we are going to do is we are going to take value here and split it into an array. Now, of course, if there's just one class name in this string, then, that's not a big deal. But in the case that there are multiple CSS classes, we are going to loop over that array, and then we are going to modify the value of the class name. And we don't want to do that like this, because not only are we looking up the L identifier and then the class name identifier, but we're also modifying the DOM each time we do this. We don't want that because DOM operations are expensive. We would rather store this within a string and then assign the string later, like this: el class name equals class name. This is a lot more efficient doing it this way. So we are going to store the class name of the element into our class name variable. And first, we will make sure that class name does not have a value, because if it doesn't, then the element does not have a CSS class, and then we can just simply assign the value like that, because we don't have to do any checking or anything like that. But if an element does have CSS classes, then we need to make sure that each of the classes that we have passed to this method do not already exist within the element. So first, we'll do class names, and this is where we are going to split value into an array. So we'll call split, and we are going to use a regular expression here to match all white space. We're doing it this way because we don't really know the type of format that these class names are going to be passed to as the value parameter here. They could be nice and neat like this with a single space in between them, or they could have multiple spaces. If we just split based on a single space like this, we would end up with an array with multiple elements that we really don't need. So if we just use white space, then this will match all of this white space here, And then, so we would have an element of foo and then an element of foo2, and then it would match all of this white space here. And then we would have an element of foo3 without any white space within the elements. So we have our class names array, and then we need to get the length of this array because we are going to use a for loop. So for var I, this is our counter. We will go as long as we have class names, and then we need to increment. And then here, basically we want to make sure that each of the classes within the class names array are not assigned to the element already. So if not this has class, we'll pass the element and then class names. Then we need to match our parentheses. Okay, so if the element does not already have this particular class name, then we will go ahead and add it. So we will do this, add a space, and then class names. All right. So whenever the loop finishes, then we want to assign the class name property its new value. So el class name equals class name. And let's go ahead and do a trim just to make things nice and tidy. Now, we don't really have a trim method. There will be an extension method that we will write later. Trim is actually applied in or added to the language in a later version of JavaScript, one that of course is not supported by some browsers. I won't mention them. I'm sure you can guess what they are, but we will add that functionality on our own. So that is basically the add class method, and we'll move on to the remove class method. It needs the element object and then the value that can contain one or multiple CSS classes. First thing we want to do is make sure that a value was passed to the value parameter, because if it's undefined or 0 or an empty string or something like that, then we will clear out any class name that may be assigned. But if there is a value, then of course we want to do something. Since we can have multiple classes, foo, foo2, foo3, we want to break that into an array. So let's do class names, value split. We will use the same regular expression, and then we are not going to use the has class method here. Instead, we are going to use the string objects replace method. This will allow us to basically do two things in one operation, actually. Since we are replacing something, we are automatically searching for that particular string. So we don't have to use has class. The replace method is kind of going to do the same thing for us. But in order to do that, we need to do kind of what we did with the has class method, and that is surround the class name with two spaces. So we'll call this class name, and then el.className. And then we want the length of the class names array, because we are then going to loop through it. Our counter we'll call I. If I'll hit the right key, we will loop that many times, and then we'll increment. And since we are going to call the replace method, that's going to return a new string, so we basically want to use class name and then class name dot replace, and then class names, and then we replace it with a space like that. And then once the for loop exits, class name dot trim. So it's kind of a mix between the add class and the has class. We split everything, or we split value into an array. We basically search and replace each individual class that may be contained within our value parameter, and then we assign the elements class name property a new value, and then we call trim, because if we do replace something, then the chances of having some extra white space is a lot higher, so we will just trim there. And let's go ahead and do the toggle class method. So we will do xObject toggle class. We'll have the same two parameters that we've been working with, the element and then the value, which contains the CSS class name. Now we could take the easy way out and just say that value can only contain one CSS class name. That would work just fine. In fact, that would work for the majority of times when we would call toggle class, but there would be some times when we would want to change or toggle multiple classes at the same time. And to do that, then we just need to pretty much do what we have done so far with add class and remove class, and that is to create a variable called class names and split value into an array. So nothing there, and of course we're going to have to loop over this array. So we're going to use a while loop to do that. Our counter is going to be I, and then we are going to have a variable called class name. Now the reason we are using a while loop here is because I want to. It's a little cleaner as far as what we want to do, and that is assign each element of the class names array to the class name variable. We could do that with a for loop, but it's a lot more elegant with a while loop. So class name equals class names, and then we pass in our counter. We will increment it, and that's it. And this works because each time we iterate over these or over this array, we get some type of value whenever we pass in the counter here. But whenever we reach the end of the array, that's going to return undefined to class name, and that in turn is going to be evaluated within our condition here. So then undefined is falsy, and that will kick us out of the loop, and that's exactly what we want. So now we need to determine if each individual class name is going to be assigned or removed from the element, and we do that using the has class method. So we could do something like, if this has class, pass in el and class name, then we would call this remove class el class name, add in an else, this add class el class name. Now there is nothing wrong with this code. This works just fine. It's readable. The only thing that I'm not happy with is the amount of typing and work involved to do this. We could actually do this a lot cleaner and a lot simpler using bracket notation. Instead of typing out three methods, we would only really type out two, and that will cut down on the amount of keystrokes as well as making it just one statement. And we will do that without really causing any performance hits, so it's a win-win regardless of who you talk to. So let's do this has class name, and we are going to use a ternary operation here. If has class is true, then we want to remove the class. Otherwise, we want to add the class. And close the bracket, and then we call that method el class name. And there you have it. That is a lot cleaner in this line. Let me zoom in here. That's a lot cleaner with that one line as opposed to 1, 2, 3, 4, 5, 6. So let's get rid of that. And there we go. We have our toggle class method. Now let's write the instance versions of these methods. we'll start with prototype, the has class method. Value, we need to go there. And we are simply going to return X object, has class, pass in this.el, and then value. Pretty easy. The has class method returns a Boolean value, so we can't really chain that. But the other three methods we can. So we'll do X object, prototype. We'll do add class first. And I need to put a space there. And value. And then we will simply call the static method, add class, this L value, and then we want to return this because we want this to be chainable. Pretty easy. And the other two methods are going to follow the same pattern, so we're just going to copy and paste, and then change the identifiers. So we will change add to remove, copy, paste. That was easy. Do the same thing for toggle. And there we go. We have our instance methods. Now let's go ahead and test this. And we can do that within the browser. That would be really easier because that would allow us to use the development tools and see the results as we run these methods. And for testing, we are going to use Chrome. And that's because we can execute code at the same time and see the results within our HTML here. We could do that with Internet Explorer, but the problem is the HTML is on a completely different tab than the console. So we would have to type our code here, switch over to switch over to HTML, and that's more work than I want to do. So we're going to use Chrome, and the first thing we need to do is get rid of this here because that's causing an error. And we don't really need that either. We do need this foo object here, so we're going to leave that because that will allow us just to go ahead and type in foo here. So keep your eye here on this line because we are going to make sure that these values are here. So let's do foo has class and foo. And why did we get 0? That's supposed to return true. So let's go back to our code. The instance method is not going to be the problem. So let's go to our static method, return index of, and we didn't do a comparison here. I apologize. That's very unfortunate. The index of method returns the index of whatever match the method found with the substring. It can be 0 or positive, or it can be -1 if there was not a match found. So since the method is called has class, we want to return true if a match is found. So that's why we are checking to see if index of is greater than -1. So now let's go back to Chrome, let's refresh. And voila, there we go. Let's test for foo2 or foo1, and that's false, so that's fine. But let's go ahead and add class. Now this is where we want to look here to make sure that we are adding a foo1 class, which we do. Let's go ahead and remove foo3. It would help if I typed remove class. Remove class, there we go, and we have foo, foo2, and foo1. Okay, so add works, remove works. We do need to check to see if multiple class names work. So let's add 2 class names. Let's add foo3 and foo4. And there we have foo3 and foo4. Let's remove 2 classes. Let's remove foo2 and foo3. That worked as well. So now let's use the toggle class method. Toggle class, and let's toggle foo1. This should remove foo1, so that did that. Let's call that again. And that added foo1. Let's do multiple classes here. We'll do foo1 and foo3. So this should take out foo1. Actually, let's do foo4. This should take out foo4 and add foo3. And there we go. Let's make sure that it works the other way. This will remove foo3 and add foo4. And that worked as well. So our class methods work just fine, as well as our CSS method. And that pretty much finishes up all of our style code. So if we want to set individual CSS properties, we can using the CSS method. And if we want to modify the classes that are assigned to an element, we can use one of our 3 or 4 methods to work with CSS classes. Oh, there is one other thing we need to do before going on to content, and that is write a trim method for browsers that do not support it, because we do use trim in remove class and in add class. So that's something that we need to do. We could write some helper functions. We already have 2 of those, but we could also modify the string object, give it a trim method, and then our code is just going to work. Now, depending upon who you talk to, modifying built-in objects, or really any object that you don't own, is a big no-no. For the most part, I agree with that, but I think we can make modifications in a smart way in order to make things a little bit easier for us. And there are 2 guidelines that I follow if I'm going to modify a built-in type. The first guideline I follow is only modify objects with functionality that mimics and perfectly mimics the behavior or functionality in another browser. For example, the trim method. It's in later versions of the JavaScript language and thus supported by later versions of browsers. So we want to add that feature to older browsers. So we can meet that first guideline. The second guideline is to ensure that we don't do anything with the native implementations. So if we are going to write a trim method, we want to make sure that we don't do anything with the trim method in the browsers that support it. We cannot write any code that's going to execute any faster or more efficiently than native code. So we want to leave that alone. We're already abiding by rule number 1. So in order to satisfy rule number 2, all we need to do is use an if statement, type of string.prototype.trim. If it is undefined, then we can assume that it's safe to write our own. So we'll do string.prototype.trim equals function. It does not accept an argument. And then we want to return a string. We'll use the this keyword because in this context, this is pointing to whatever string object we're working with. And we are going to replace the beginning and trailing white space with an empty string. So first we will match the beginning white space. We will use a regular expression to do that. Then replace it with an empty string. Then we'll call replace again because we need to do the same with the trailing white space. We'll use a regular expression for that. And there we have it. Let's add in a section here because we have one for everything else. We'll call this language extensions. And if we need to add any other language extension, then we can do that within this section. So now that we have completely finished the style portion, let's change gears and look at content and how we can manipulate content with our library. We manipulate content in 2 different ways. First, we can use the standard DOM API, which allows us to create elements and text, and then we can add or remove those nodes to and from the document. We can also use the inner HTML property, which is not standard, but it is supported by every browser. We could spend another hour or possibly even 2 or 3 hours writing a complete content manipulation API, but we don't really have that kind of time, and we have kept things rather simple. Of course, we have added more complex functionality as we've needed it, but for the most part, we've started simple, and we are going to do the same thing here. Really, the only thing we need to keep in mind is to make sure that our API makes sense. And for example, we are going to write a static method called HTML. And it is going to set the inner HTML property of an element. We will make sure HTML has a value. If it does, then we will set the element's inner HTML to whatever HTML was passed to the method. Otherwise, we will return the element's inner HTML value. Now, this particular method really doesn't make sense. If we are calling it, then we have at our disposal this element object, and in which case it would be more efficient just to write that code out as opposed to calling the HTML method. But this would make sense as an instance method. Let's say that we have an X object instance called foo. And if we wanted to set the inner HTML of the element that foo wraps around, we would have to do foo.l.innerHTML and then assign it whatever value that we wanted. So instead of taking this approach, we could convert this static method into an instance method. So we'll put it on the prototype, and with a few changes, we could make this a usable method that we could use with our XObject instances. So we'll just put this in a few different places. We will return this to make the HTML method chainable if we are setting HTML. Otherwise, we can't really return the HTML data and return this at the same time, so we don't need to return this here. And then, instead of using this line, which is on 229, we could just call the HTML method if I can select it all, there we go, and that cuts down on all of the code that we would have to type in order to set the inner HTML or get the inner HTML. Now we can take the same philosophy with appending data to an element that's wrapped around an XObject instance. Because, for example, if we were going to write a static method, we'll go ahead and do that, called append. We would once again need the element object and then whatever data we wanted to append to it. Now, once again, if we have the HTML object at our disposal, it would be easier just to use the standard DOM API. So we want to make this an instance method as well. Let's go ahead and do that. We'll add .prototype. We will get rid of the L parameter. And now we have the ability to append multiple types of data, because we can append raw DOM objects, or we can append the element object wrapped around another XObject instance. So first, let's handle the DOM object. And we want to make sure that we have an element, so we will use the node type property. We want to make sure that it is not undefined, and we also want to make sure that node type is equal 1, because that means that we are dealing with an element. And then all we would need to do is this L append child data. Now for XObject instances, we kind of do the same thing. We do data, and then we use the instance of operator, XObject, and if that's true, then we will do this L. We will do append child as well, but then we will use data.L. Now, it would be helpful if we could also pass string data to this append method. We kind of already have that capability with HTML, but since this is a method to append content to our XObject instance, it does make sense to allow string data, which means that we would have to set the inner HTML property again. So we will do else if type of data equals a string. Then we will do this L inner HTML data. Now, instead of calling this .html, we are using the inner HTML property here because this is more efficient than calling the HTML method. And then we want this to be chainable, so we will just return this. The last method in part 2 that we are going to write is a method called createElement. It is going to be a static method, and the reason it's going to be static is because we are going to create raw DOM objects, and that is a utility that we will want to take advantage of regardless of if we are using raw JavaScript or if we are creating XObject instances. So this will be static, and we are going to pass it an object, and the properties of this object are going to mimic the properties of an actual HTML element, or at least it will for the most part. So the first thing we want to do is make sure that there is a value passed to the method. And we also want to make sure that there is a tag name property, because if it doesn't have a tag name, then what's the use of calling createElement? And if we need to, we are going to throw a message, or throw an object with a message property, and we are just going to say invalid argument and be done with that. But if this check passes, then we can continue on. We will create our element object, document.createElement, and then pass in the tag name property. This creates our element, and then we can start setting the ID and class name and things like that. So we will use a different type of syntax, and I will explain it whenever I finish this statement. Okay, what we have here is a logical AND operation, and the logical AND operator evaluates both operands. It looks at the left side, and if it's true, then it evaluates the right hand side. But if the left hand side is false, then it just short circuits and it doesn't even bother evaluating the right side, because both operands have to return true in order for the whole condition to return true. Well, in the case of this code, if object.id is a truthy value, then this right hand side is evaluated, which we are setting the ID property of the HTML element object. But if object.id is falsy, then this code does not execute, because the JavaScript engine short circuits out of that logical AND operation. And we are going to do the same thing with the class name property. We will do el.className equals object.className. And we will do the same thing for our own property in order to set the inner HTML property. Of course, we could call this HTML or inner HTML, but I like HTML better. And we will just do inner HTML equals object HTML. This is nice and all, but it would be nicer if we took attributes into account. So let's say that we have an attributes property, and it would actually be an object. And the properties of this object would be the name value of the attribute that we want to set. So, you know, it could be align and then center or something like that. So we want to make sure that there is an attributes property before we do anything with it, because if it's not there, then we don't have to worry about it. So we want to make sure that that's not undefined. And if it isn't, then we want to enumerate over the properties of our attributes objects. So we'll make things a little bit easier and assign object.attributes to a variable, which is attr, but I'm going to call it attribute, and then have a variable called prop for each property name. We'll use a for in loop, ttr, and once again we want to call the has own property method. And then if that's the case, then we will set attribute. We will pass prop for the attribute name, and then attribute bracket prop bracket for the attribute's value. Let's also add support for creating child elements, because we do have a parent element, this L variable here, and we could create its children if we wanted it to. So let's have a property called children, object.children, and instead of being an object like the attributes property is, the children property is going to be an array. And it's going to be an array of these faux element objects that we are passing to create element. This way we can keep calling create element as we loop through the children array. So first we need to make sure that object.children is not undefined. And then we need to create some variables for our loop. We are going to use a while loop. And I is going to be our counter, so while child equals object.children, and then we will increment our counter. And then here's the real easy part. We append child, and then we call create element, and then pass in child, because, and I need another, there we go. This works because the children array is going to be an array of these faux element objects. So we are passing in each of these objects that's going to contain the information for each child element. And as each child element has its own children, it will just create those as well and append them to its parent object. So we can have, you know, as simple of an HTML structure, or we can have a very complex one. It really doesn't matter. As long as there are children, this is going to create those children for us. And then last, all we need to do is return the element object. You might be wondering why we test for undefined when testing object.children instead of testing array, which would make more sense. That's because arrays are objects in JavaScript. If you did type of object.children, you would get object instead of array. But we could add to our condition here. We could do object.children instance of array, and then this would ensure that 1, we do have a children property, and 2, children is an array. And that is probably something that we will change later on, but for now we are just going to keep things simple and just leave it with this one simple check. Now that we have these 3 content methods written, we do need to test them. So let's go to our HTML page. We don't need this foo variable right now, so let's, well, we can leave that. Who cares? Let's first test the create element method. Create element, we are going to pass an object. The first property is going to be tag name. We will create a div element. Let's give it an ID of foo2 because we already have an element with an ID of foo. And then let's give it a class name of CSS-class. Let's add a child element. This will be a div element as well. We also need to test the HTML property. Let's do bolded text that says hello create element. And we do need to test attributes. So attributes, this is an object, align, center. That's for attributes, that's for the child element, and that's for children. And that finishes that. We do need to add it to the document body, append child. L. Alright, so let's test this out. And it looks good so far. We already have a div element here. We're not concerned with that, but we do have another div element that we did create. It has a class of CSS-class, an ID of foo2. If we drill down, we have another div element with an align attribute set to center. Then we have our HTML content. Let's, oops, what's my keystroke? There we go. Let's test Chrome. That looks like to be the same thing, but just to make sure, that looks good. Great. Let's pull that down a little bit. All right, so our create element works. Let's test the append method. So we will comment out that line of code, and let's append this to foo. So why is there append child? That's interesting. Please bear with me. Let's look for append child. Huh. IntelliSense went a little wonky on me. Oh well, who cares? We know append is there, so let's just append L. So now we are appending this element that we created with create element, and we are appending it to our div element up in here. So let's go back to Internet Explorer. We shall refresh. Looks the same, but let's drill down. That's great. It was appended to that div element. So there you go. Let's open up in Chrome. Refresh. Looks the same, but the markup is different, or at least the structure is different. So that's great. Let's now create an X object instance with this element that we have created. And if we go back to our constructor, we can do this because we first test for a string for an ID, and then we test to make sure that object could be an object with a node type property and be an element. So this is perfectly legal code. If we refresh, everything looks fine. Let's drill down. I'm not going to zoom in because everything is fine. We'll make sure it works in Chrome. Everything is the same, and that's perfect. Okay, so our append works for raw DOM objects. It also works for X object instances. We do need a test for HTML. Hello, append. Let's refresh. This should append that to the element, and it didn't. It overrode it. So let's go back to our code. Let's find append. And it did that because we are setting the inner HTML. We don't get the HTML and then set it again. So first we need to create a variable. We'll just call it HTML. We'll set it to this.innerHTML. Of course, we could use the HTML method, but this, once again, is just a little bit more efficient because we don't have to call the method and perform that particular test. So now let's append data to HTML. Let's go back and refresh. And there we go. We are appending content now. So that is the type of behavior that we were wanting. So our append method is working just fine. Now we need to test the HTML method, and that is supposed to overwrite the HTML. So let's go back. And that did nothing. No errors. So it's some type of logic error. Let's see, if not HTML, that is the problem. Because we are setting HTML, we want to make sure that we have a value there. So I apologize for that. I'm sure you were screaming at me through your computer screen, but at least we fix it now. It's better now than later. So let's go back, refresh the page, and there we go. We have replaced that HTML content. Let's also make sure that we can get the HTML content. So let's just do an alert. Refresh. There we go. Hello world. And it doesn't have any HTML elements because, all we have is the text there. So that finishes up part 2. Not only can we interact with the user with events, but now we can interact with the web page using our style manipulation and content manipulation methods. In part 3, we are going to interact with the web server by adding AJAX support, and we will probably look at how we can start using our library to create some stuff. So once again, my name is Jeremy McPeak. Thanks again for watching, and I hope you enjoyed it.